All right, so first things first. As I said, this is a tweak of one I did at the high school level with a lower level class. They don't have to do all the work. You're going to have to do all the work. You're going to have to show the matrices, and you're going to have to do show all the matrices for the transformations. I expect a little bit more than that, a lot more from them at the end on the write-up piece of it. Also, there's an extra piece in here which I would like to make better and more awesomer. It's a suggestion right now, but knowing that I always have people who are engineers, this will all be up on the thing. Don't worry about it. I got it. You can write it down if you want, but I'm just saying.
Okay, cool.
So I know a lot of you guys program, so like Python would be, I think, a really cool way to do this. Python programming stuff, this, that, yes. I think it can be done. I don't know how to do it. Don't ask. I would like to see it done that way so that I can have some, in the future, some more ideas of how to do this better. But I think it's probably nice. Now, linear algebra stuff, obviously one big piece is for transformations, geometric transformations. Okay? So this is for them. I used it in a corporate, a school-appropriate corporate logo. So, for instance, let me just go grab a corporate logo here somewhere. How about we do a Nike swoosh? All right, there it is. Cool. Give me a picture of it. There we go. Cool. I don't know. Oh, no way. I'm gonna do this now. Oh no! Stop it! Stop it! Stop it! Stop it! This one. Cool. Copy. I think I can do it this way. Anyway, there's a program called GeoGebra, which I think is very helpful for this. It's not the only thing, and if you want to do it differently, it's totally up to you. Totally don't care. If you do the GeoGebra Classic, nice. Here it is, and then you can. Think about how to do this for a minute. I can just paste. No, that's why I have to save the image. Wait, I have to save it. I forgot. Save image. Disgusting. Oh, look, I can see. Cool. Save image as. Nice. Nike. Cool. Whatever. Don't care. Whatever. Now, what you can do is come in here and you can import it, and it's under. I just have to look at the right one. Import image. There it is. Ha! Image. Choose file. Nice. Nike. Cool. Whatever. Okay. Nice. Notice it puts 2 points on here automatically for you. There they are. I'd like to use those points plus, I forget how many points I said earlier on the page, for a grand total of however many points it's going to be. We'll look that up in a minute. The idea here is we're going to transform this guy. We're going to transform. We're going to rotate it, reflect it, do all kinds of whatnot to it, and it's kind of fun to do that. Now, you can grab these points. In theory, you can grab these points, I said. And you can do this, for instance. I don't want them at the origin, but you could put them at the origin. You can put them wherever you want. For instance, let's say you want this one at -12. You can double click in here and you can change that positioning. Okay? I just think that's kind of a neat program. You can zoom in and out to your heart's content. Zoom out, sweet, whatever.
So we could zoom it into a very small.
Yeah, I don't really care. It's whatever you think. Okay, now me personally, I like this because I'm not going to program it in Python because, well, me and programming, not so much. Those of you that like to program, you think, well, I could get a little extra credit for doing it in programming. That's why I want to do it that way. Plus, I'd like to learn something about programming. Okay? And I don't think it's very hard because it can't be very hard, for God's sakes. Here's some points, you can do some transformations and then shoot the picture back up again. It can't be this difficult. Okay? I say it can't be, but it surely can't be that hard. I can visualize it, I just can't make it do it, right? So, here's the game. You're going to, as I say over here, you're going to put 3 more points on the image in addition to the 2, so you have a 5 total. And you're going to keep track of them each time you make the transformation. So, keep in mind when you do this, your actual points matrix will be like this, maybe. Where's my thing? Where's my drawing program? That's not the thing I need. Whatever. Remember, your points matrix will look something like this, perhaps. Or what have you. Right? This is X's and Y's. This is 0.1, 0.2, 0.3, 0.4, 0.5. Yes? When you're done, you better end up with a 2 by 5 matrix every time. Otherwise, you've lost a point somewhere. That would just be weird. And there you have it. Okay? Now, we mentioned briefly the other day about rotation matrices and whatnot. That's cool. We can talk about that all you want. Clearly, the things that you can do are you can translate things. If you recall back to geometry, I really don't remember geometry in high school much, except that the teacher was weird. And that was the year that girls became a distraction, not an annoyance. Okay? And I got a D. I remember that. But whatever. Okay? Now, translations. If I'm going to translate something, what am I doing to everything? I'm moving it, sliding it, yes? So what am I doing to all the X's? Adding or subtracting something, yes? And I'm doing the same thing, I'm doing something different, but to the same different thing to all the Y's, yes? So it'd be a plus or minus situation, I suppose, yes? Right? And what else can we do to these things? Well, we can dilate them. Obviously, dilating makes the whole thing bigger, yes? Be careful of that, though, because where are we dilating it from? Okay? So you're going to have to do, I'm not going to tell you everything you need to know about it, you just have to think about it a little bit. Dilating it about the origin or dilating it from a point. If J got bigger, my feet technically, like let's say my heels, if my heels were at the origin, then I kind of like put it this way. If I get bigger, my heel's not going to move. My toe might get bigger this way, everything might grow away from my heel, but my heels don't sink into the concrete here, yes? That's just weird, okay? So when you dilate things, everything gets bigger proportionally speaking, of course, but they all happen around about the origin, okay? So, but if you wanted to dilate it about a point, which is something I want you to do, that point's probably going to have to get moved to the origin to make that happen, yes? So just kind of think about those things. These are going to be composite situations, like you do f of g of x, kind of things like that, where you have to do this function first, then this function, then that function to get where you want it to be. Okay? So dilations, again, making it bigger, multiplying by a scalar, of course. But the question is, which point are you dilating it about? For instance, here, if I just dilated it, everything would be hunky-dory because every one of the points is at the origin. But this point, no points at the origin now. Now when you do this, yeah, it's twice as big, but every point is twice as far from the origin. And so it's not going to be dilated from a point. Well, it's dilated from the origin, but it's not from one of its points. Okay? If you dilated about one of its points, that point won't have moved. Everything else got twice as far away, or 5 times farther away, or whatever it is. Okay? Dilations. You can also do rotations. Rotations. You can obviously rotate either around the origin or around a point. You're going to have to do some work on that because just a straight rotation will not be around a point, so you're going to stop and think about, well, how can I make this happen if I want to rotate it around a point that's not the origin. Okay? Keep in mind that if you're multiplying, whatever you're multiplying by, what kind of things could you multiply by here? Obviously, you could add a 2 by 5 to this 2 by 5 and a 2 by 5. That's hunky-dory. And of course, you can multiply by a scalar piece of cake. If you're going to multiply this thing, what would it have to be? I suppose you can multiply it by a 5 by 5, because remember, you need to end up with a 2 by 5. Not really sure what a 5 by 5 is going to tell me, though. That feels weird and kind of dirty. You could also multiply out front by a 2 by 2, yes? So kind of keep those things in your mind. There is a section 3.6 or wherever it was back there. There was a little bit more of a blurb about that. Again, this is a project. You can kind of read up on it. It would be swell. Okay. Glad to help, of course, but there it is. Also, some reflections. Mm-hmm. Reflections about what, Jay? Well, that's a good question. You could reflect it across you could do across the y-axis, across the x-axis, the line y equals x. You could reflect it across any x equals a, or x equals, or y equals a, b, or what have you, okay, and your choice on that deal, okay? The only tricky thing about this corporate logo is when you do the reflections, you're gonna have to do it somewhere else, like in Photoshop or something, and somehow flip the thing over. I don't know how to do that. That's what I've had to do in the past. Kids are like, oh, what am I supposed to do? I don't know.
So you're not actually making us like...
I'm a dang teacher about that. This is just a learning how to use some linear algebra to play some games. You with me? I would prefer if you could do it cooler, some cool math with some Python stuff, and bring some of that into my class. Again, you're the guinea pig class, right? You could totally wimp out, and this would be pretty straightforward, easy little project. But bear in mind, if you do the easiest way out, I'm going to grade you the hardest. Okay? You swing for the bleachers a little bit. Oh, that's pretty good. I like that. That's probably much an A there, or whatever. Yeah, whatever. What do you think?
So you're not making us like assign points onto a specific image somehow in GeoGebra?
Oh, yes. But watch.
But the points are just representative. We don't...
Well, sure.
Okay.
But like right here, for instance, you could grab this little pointer tool, grab a point. I'm going to put a point right at the top of the end, because I guess why not? One on the E and one on the tail end of the swoosh, or wherever you feel like it. I think it's easier if you put it there, because then when you blow it up, twist it around, you know where those points are supposed to land.
But what I'm saying is that from there, we do stuff to the points, but then we Photoshop the image too.
Yes, you
Okay.
do stuff to the points, then when you get done, you'll put the points where you said they're supposed to be, and then you'll just put the new image, lay it over the top of those points, and it should match up.
Okay, cool.
Now in a thing like in Python or something, I think it'd be really cool if the image you would just say something like rotate 30 degrees around the origin, and then all of a sudden, boop, here it pops up over here. That'd be pretty sweet. Okay. Again, for those of you who are, you know who you are, total perfectionists, and you already have an A, maybe don't spend 50 hours doing this. Okay, unless that's something you really want to do, in which case go for it. But if you're like, I really need a little extra credit, all right, then this would be the time to do that, get a little extra going there. Okay. Again, I think Python is the thing that would work pretty well for this, right? All right. MATLAB would probably play the game too, sure.
Can I do it in Java?
Do it in Java, you can do whatever you like,
If you
friend.
don't have it download, you won't be able to open it.
Save
What?
it as an
You won't be able to
HTML.
open it because
Can't you
you
just
Put it up on a web page.
Yeah, can't you just save it as an HTML or?
Can't you just embed it on a web page
have to
somewhere?
ask questions and participate in my project.
You know how Java can't find like
Oh yeah, well yeah, that's a good point. I don't know. If you need help, you have to come and see me in person though, because sending it to me and expecting me to figure out what you're doing is probably
It'll
not.
ask you specific
Not.
questions.
It's probably not the best. What am I doing wrong in my programming? I don't know. What's up? You're using Java. Yeah. No.
Extra credits for people that don't do programming?
Listen, it's I don't know. I'm open. I'm open to some ideas. All right. Now again, I've given you some. You must. Oh wait, where'd it go? Here it is. Good. Now here are some suggested transformations. These are just some suggested transformations. I'd like to see you do about 7 of them. These are just some ideas. Please don't do like 5 I will not give you a good grade if you do a bunch of translating. That's just ridiculous. Okay, make them more interesting than that. Okay, I moved it over and then I moved it back. If you're doing that, it better be a nice, cool programming thing, and like flash at me when it gets over there. Ooh, look at me, something like that. Then maybe. Okay. Now, when you're finished doing all that, I would also like to have you put the image back where you found it. What do you mean? Oh, I forgot to mention. So if your first thing is to reflect it over the x-axis, that's step number 1. Now you're going to take that image and you're going to rotate it, for instance, 30 degrees around the origin. Then you're going to take that image and you're going to translate it down to the left or whatever. Then you're going to take that guy and you're going to rotate it 160. So when it's all done, what I'd like you to do is to be able to get it back from whence it came. Okay? And is there a better way to do it than just saying undo, 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 undo? Okay? What I'd like you to be able to do is say, listen, I can do it there in 3 steps. Okay? Let's say maybe you have to reflect it over the y-axis again or something, but then shift it down and twist it or something like that. You should be able to get it back in about 3 or 4 steps pretty easily.
Does a reset button count?
Control Z, Control Z, Control Z. There it is.
If you get like the final matrix from all the transformations, then you can just do the inverse of that, and that'll be one step,
What?
right?
What?
Like if you,
You're saying, oh, I got you. But see, some of these are additions, some of these are multiplied by scalars. Some of are, we're going to be multiple steps, so it's not quite as easy as that. It would be nice if it was. By the way, your final answer is going to be a 2 by 5, so it won't have an inverse. So it's not quite that easy, okay? But this is kind of the right idea. So put it back from whence it came. But again, what I want you to do is that you start with an original, you do one thing to that, you take that image, that becomes what you do the next thing to, you take that image, that becomes the next thing, and so on and so on and so on. You're not going back to start over fresh every time. Does that make sense? Now, I guess extra credit if you don't Python or program or Java or whatever, you can add a few more of these steps to me or something.
I'm already swirling things around in my head.
Okay. But again, this little GeoGebra thing, I think it's just helpful for visualization. That's the only reason I did it for the students, because they could, okay, they did the math over here, they plot the points where it is, and then they take that photoshopped image, should match up with it. Okay, and like, oh yeah, I did it right, yay me. Or, Mr. Groom, I know I'm right. Yeah, your points say you're not. So, I don't know what to tell you, kid. So again, that was a lower level class. Obviously, I want this to be taken to a little higher level than that. They spent a lot of time. And I showed them how to do rotation matrix, and I showed them how to do all this stuff. And it was more than I probably should have chewed off of those kids, because whatever. My buddy did this kind of thing back in the day, only he didn't use matrices at all. He would just talk them through doing transformations, because GeoGebra and some of the other outfits will do some different things. I can't remember, he didn't do GeoGebra, he did something else. Anyway, then he was all done, basically. He had them print off the pages. And then he has like those little coloring, like those little flip books, like a cartoon flip book thing. It was interesting, but it was kind of weird too. When he was all done, I'm like, I don't know, it's too much. I want to do matrices with these guys. That's why I did it this way before. Yeah, cool. All right. Nice. Yes. Cool. Option 2. Option 2, you're going to read about Markov chains in games such as Chutes and Ladders, Monopoly, things like this. Okay, for instance, I'll show you a quick video here in a minute. One of my favorite mathematicians, which I know sounds weird. Well, 2 of my favorite mathematicians. She wrote a book about Monopoly and how she did the Markov chains to figure out where you're most likely to land in Monopoly. So which should you buy, which things should you do. It's pretty sweet. She went through and did it that way. The other guy is more like, okay, the other guy's more like me from the standpoint of that's exactly how I would have done it, except that he wrote this giant code, I think in Python, which is not how I would have done it. But he simulated a bunch of games, and that I could have done pretty easily. Okay, I don't think I would have done it the way he did it, but that's what I would have done. And I think he simulated like 1,000 games or something. And over 1,000 games, his stuff tended towards hers, which was the actual theoretical business. Okay, it was kind of neat to watch, kind of see that. The idea being is that Markov chains is all about probability. Now we've not talked much about it because, well, it's just, I don't know, not a lot of time in here. It's one thing that I've not had enough of to where I would feel, where I feel like I do a great job of explaining it. I can do it, but it's not my favorite thing. Let's see here. Yep. Yes, here we go. A, B, C. I came into C. Cool.
Literally statement.
Okay. So the whole idea of Markov chains has to do with probability. This is a fairly nice and easy deal. Okay, as you can see, from A, we can either go to B or to C. Now some people go, oh, is it 50-50? No, I'm telling you right now, from A, if I'm at A, I go to B 70% of the time, and I go to C 30% of the time. Yes, I just made those numbers up. You cannot go from A to itself, but you can go from here to here, and you can go from A to C. I'm just telling you it's about from there to there. Okay? I'm making these numbers up, in case you're wondering. Okay? What would it really be? Well, it would be this. For instance, it could be a situation where You know, do you go, when you're going out running errands, obviously you're not gonna go from your house to your house, that's just weird. But from your house, you might go to B first, or you might go to C first. Or, yeah, you might go here or here. And maybe you go this one more often than you go to this guy here, okay? There's a lot of things in our lives that are like that, right? We have tendencies. Why'd you go here today? Well, the traffic was bad. Okay, yes, we all know why you did what you did. That's exactly what we all do, right? You come up to a situation, I usually do this, but sometimes I do this if something happens, or I left work late, so I did this, or whatever. And there's the idea, this is how we live our lives based on probability frequently. Notice that from B, I can go 2 places. I can either go back to B. I cannot go to A from B, yes? There's no way I went from back to A from here, yes? The lines don't show that. So once in a while I go here, the rest of the time I go here. That's cool. And then from C, it looks like, I need to add some more lines is what it looks like, you moron. There we go. Nice. I'm gonna add a few more lines. There we go. 0.3, 0.5, 0.2, it better match up. So C to A, 0.5, C to C, 0.3, C to B, 0.2. That's what's called the transition matrix. It's the probabilities that I will go from here to there. Okay? Now over time, as you go around the thing, what's going to happen? Well, so if I start off at A, clearly if I start off at A, I go over here to B. Well, that's cool. So what that means is on that first step, where could I have ended up? Well, I could have gone to A, or I could have gone to C. I can't go from A to itself. But what ends up happening is you end up taking this guy and you multiply it times itself. Okay? And what ends up happening over time, as this transition matrix is multiplied again and again and again throughout there, it tends to settle in on certain percentages of where you will be at. Okay? This is where you'll tend to end up being. And that's kind of what they did with this Markov chains when it comes to this probability thing. For I've seen it done for Chutes and Ladders. I've seen it done for Monopoly.
You mean you just multiply it by itself over and over again?
Well, that's kind of the idea, but you need to read about it. You'll see. Okay, but this is the general gist of it here. Okay. Now, I don't want to take the fun away from you from having to do it. Okay. So in Monopoly, of course, you're rolling dice. All right. And Chutes and Ladders. Is it a dice or is it a spinny spinner? Is it dice? No, from the Chutes and Ladders. It's been a long time since I played that game.
Do you do it with card games too?
Oh, is that Sorry or is that Chutes and Ladders? Oh, Chutes and Ladders because, oh no, what's the one? Candyland.
I was thinking of Sorry.
Candyland.
Monopoly
My kid plays that.
Yeah, no, I got that one. Oh, today? Hilarious. The most annoying kid in my class, in my third period class, he never shuts up. I'm like, dude, I need you to videotape for me. But here's the deal. You cannot open your mouth. Because I can't have you like making commentary the whole time. Dude was quiet the entire time. Best decision ever. From now on, I'm just gonna go, here's this camera, I'm taking the batteries out of it. Here, just point this at me, will you? No, but you can't talk. It was the best thing ever. Oh, it was like so quiet. You got stuff done, he wasn't constantly, but anyway, midway through he's like, hey, you dropped something. He kind of whispered at me, I'm like, I think you did. Because he's a Dungeons guy, he's always got like 87, he was this giant gold dice fell out of his pocket. Anyways, that's reminded me of that. Yes, he's always D20 and then D this and then D that. And, all right, it's good time. So YouTube's, I will show this one. This makes me happy. It's Hannah Fry, Monopoly. Yes, here she is. Love it. Yep.
I'm here with Hannah Fry,
Come
and
on.
we are going to be looking at the optimal mathematical way to play Monopoly.
Yes, indeed.
I think. So you were looking into this because you were writing a book. I've got it here, The Indisputable Existence of Santa Claus.
A lovely looking book,
Look at it, it's shiny and everything. It's so lovely. Oh, and it's been signed by the authors. Look at that. And so you were writing a book all about the mathematics of Christmas, and in the UK
serious Christmas tradition.
This tradition to argue over Monopoly. Right, so in here, there's your book.
Yeah.
Right, what did you find?
Well, the key to winning at Monopoly, being everyone at Monopoly, is realising that not all sets are created equal.
Right.
So there are some squares that are much more likely to
Pause.
land on others,
Pause.
and therefore
Pause.
will make you more.
Yes,
Pause.
this is the point, because a lot of people think, well...
Pause. Let's do this. I just got to think about it. This one has better speakers, maybe-ish. Maybe. Let's do this way. YouTube's. That's not how you spell YouTube, Jay. Oh, Hannah, Fry, Monopoly. All right, a little bit of everything. Here we go. Wait, stop. Here we go. Wait.
Looking at the optimal mathematical way to play Monopoly.
Yes.
So you were looking at this because you were writing a book. I've got it here, The Indisputable Existence of Santa Claus. It's a look at it, it's shiny and everything. It's so lovely. Oh, it's been signed by the authors. Look at that. And so you were writing a book all about the mathematics of Christmas. And in the UK is tradition to argue over Monopoly. Right, so in here, there's your book. Right, what did you find?
Well, the key to winning at Monopoly is realising that not all sense.
Only one that's done that. There's quite a bit online about that. But Chutes and Ladders, I think this website's pretty slick. Talks about the 10 by 10 grid. I think it's this one where they show. Yeah, I think it's this guy here where he talks about. Yeah, there you go. So then you can talk about how you, because the whole idea is if you end up on the very top before you run out, that's when you win, right? When you're on the top. But I forget. It's been a long time since I played Chutes and Ladders, unfortunately. Anyways, it talks about the percentages of finishing in a certain number of rolls, and then there it is. But anyway, so then he just walks it through, and somewhere, I think it's on this one, there's this part, that's part of his matrix. You see that he kind of cut part of his matrix off. You can see what's going on here. Obviously, if you're on number 10, all right, then the chances you get to a number 11 are 1, 6, 1, 6, 1, 6, and so on and so on out to 16, obviously, yes? And the same thing is true all the way across. The problem, of course, is if there's a ladder there, then you don't actually end up, let's say on 15, you end up on the next line up, because obviously it jumped you up one. So for instance, if you're on 18, you can get to 19, but you can't get to 20 because on 20 there's an actual spot that shoots you down, I think, somewhere. That's the deal. It drops you back down somewhere else, whatever. And you can see this. Well, he used snakes. Because he didn't want to like get sued by somebody. What did he call it up here? It was called snakes and ladders. Yeah, I don't know. It's an English thing or something. I don't know. Anyway, this is the game. So here on this one, you can end up here 1/6, or you can end up 2/6 to get on to 53, and then 1/6, 1/6, and then you end up on 67 1/6 of the time because you would have gotten on a ladder and climbed up to it. That's the game. That's how these Markov chains kind of work. So he shows you his transition matrix. Notice that his is a 101 by 101 because he uses the 0 square, which is the starting position. That's how he did it. Hannah's would have been a 40 by 40 on Monopoly. So you start at go, and there's 40 squares on the board. Obviously, for starting at go, you cannot end up on the first. There's no way to land on the first square. Yes, on a Monopoly board on your first roll, right? So you land on the second square, all the way over to the 12th square. Yes, and of course it'd be 112 or 136, 236, 336, 436, 536, 636, 5, 4, 3, 2, 1 again, right? Because there's 11 different numerical outcomes, but there's 36 outcomes. And so you can kind of see how that goes. What I'd like to see you do is to just check out a situation like this, see the math that they showed. If there's stuff like this where they left out some of it, if you want to include that, like here's the whole full transition matrix, do it in Excel, however you want to do it, I don't really care. Fill in the blanks for me, okay? And I don't care which one you do. It doesn't have to be Monopoly or Chutes and Ladders. Those are the two that I've seen worked out. There's a couple other ones I've seen worked out. I want to say Candyland, but then don't quote me on that. It was some other little kid game that you played back in the day, right? Similar deal. I don't think, like for instance, is it Sorry? Is that the one where you go up and back? And I don't think Sorry would be a very fun game. There's too many spots on the board. Life might be kind of fun. The problem with Life is that in terms of where you land, that's not a problem. But actually playing the game, it's all about what the next thing says, right? Yeah. So like, pay $1 million for your kid's tuition or whatever the next thing. Yeah.
So I'd say we're about 50% done with your project in Python.
Excellent. Good. I don't care.
Are you cool with us using like libraries from other sources, or do you want us to define the functions ourselves?
I don't care if you use the libraries, but you need to be able to explain what you did to me, and I want to be able to see all the matrices that you're using.
You actually will. The way that we do this and show what's going on.
Good. All right. So again, I'm somewhat open to it, and again, as always, first time people do my projects, before I get them all done up, it gets a little, I am pretty clear about where I want things to be. So right there, the non-zero ones are painted in red, strong probability. So after one iteration, those are the 6 places you could have landed. Okay? Those are the 6 places you can land. If you landed here, apparently you took a ladder to here. If you landed here, apparently, or somewhere here, maybe you took a ladder to there, I guess. All right? That's after the first roll. After the second or third or fifth rolls, I can't read, maybe I guess it's the second roll. These are some of the places that you could have ended up. And over time, those are all going to get dimmer and dimmer and dimmer and dimmer and dimmer. All right? Other ones are going to start lighting up, pinker, pinker. And then over time, what's going to happen is you're going to see kind of a heat map of things start to show up. And over time, I mean, you keep playing long enough, where are you going to see? Everybody's going to be done eventually, yes? The idea is going to take you more than 100 rolls to get there it's not going to happen, all right? So you think, oh, this takes forever to play. Well, after 20 rolls, you can see that for the most part, there you go, you're still up there in the top, just pretty much. The very lightest, whitest ones, they're pretty much impossible for you to be there anymore, okay? The semi-pink ones and the little darker pink ones, you're more likely to be there after 20 rolls. All right, remember, you got 100 squares, you've got 100% to go around, yes? None of them are going to have a very high probability, okay, if you think about that. 100%, 100 squares, divvy it up. So obviously that red one's got the most probability, but the rest of them all have a little bit of probability sprinkled over them, okay? So none of them are going to have a ton. Again, I'm somewhat open-ended on this piece. Find one that speaks to you. I want to see the Markov chain piece. I want to see the transition matrix, the whole thing. And then I want to see some of the in-between steps, filling it out, and see if you can corroborate some of what they came up with. Okay, I know I've looked at this one and several others for Chutes and ladders, because I think it's kind of an easy one to get your hands on. It's easy in some ways. I think maybe it's easier. It's easier than Monopoly, because you just go up or down. I mean, that's all, there's nothing to this one. It's a little trickier in that your matrix is so much bigger, right? But most of your matrix is blank, because, for instance, if you have 100 across here, or I guess you did 101, but you get the picture. Uh-oh. Okay, this is 101 of them. If you're on position 19, right, you cannot get to position 1, 2, 3, 4, 5, probably, at least if you're, well, for the most part, you can't get there. So most of these will just be, oops, I didn't want to be right up there. Most of these will just be zeros, yes? Because you cannot get here. Obviously 20, you can, in theory, you can get there because it's a dice, yes? And so, I don't know, unless it's a ladder, in which case you end up somewhere else, or a chute, you end up somewhere else, okay? But this row is pretty much going to be blank, except for the 6 places you can actually end up, okay? Or usually 6 places, because you might climb up and then, I forget how the dumb game's played, okay? So this one's going to take a little more writing, a little more reading. Want to see the matrices, and then I want you to see if you can then make them work out. If you're doing this one and you want to use Excel to do this, I would highly recommend it. Let me just pop that up real quick. If I have a transition or any matrix, I'll just show you a quick matrix multiplication on this guy. Of course, then you can just write your own. You can write your own VBA code to do this quickly in Excel. If you wanted to, even I could even do that, for God's sakes. Oops, that's too much, stupid. Cool. So if you wanted to take that guy and multiply it by this one. Oh, nope. Nope. Try again, dummy. There you go. Cool. So if you want to multiply those guys, 2 3x3s, it's going to give you another 3x3. In Excel, the way to do it is highlight here first, equals mmult. Okay. And then grab the first one. Oops. Yep. Comma. Grab the second one. Nice. Control, Shift, Enter. Give it to me. Come on. Control, Control, Shift, Enter. There you go. Bam. And then there's your answer matrix there, and you can just continue on like that. The thing I like about that is it's kind of easy to do. You can obviously then always go back and reference your first transition matrix. You can do it a couple different ways. For giant matrices, though, it's kind of nice to do it this way in Excel because obviously Excel's made for giant matrices like this. Obviously, good luck on your 89. Okay? Good luck. So the nice thing about this is you can do it up like this. Again, completely up in the air in terms of what you do. I'm good either way. And yeah, if you're going to program it, that's fine. And no, I don't know how long it's going to take to program. I don't know, and I don't care. Guinea pig here. Guinea pig here. So I'm open to suggestions. I know this is going to work, just like I knew my first 254 project years ago was going to work. It tweaked and blossomed over the years into different things. But I didn't know what was going to happen the first time. So we'll see what plans out. Questions, comments, concerns? All right.
So
Yes.
if I understand what two options are, the logo, and we select several points of the logo and put that into matrix C, and then we cause it to do the different
Bunch of different
reflections.
stuff. Those are like just
Okay.
7 ideas.
And then you'll just see the image distort or whatever.
Right.
Right. Or the chains with whatever game of our choice.
Yeah.
Okay.
I would definitely pick one that I've seen before, though. Like, it's a game you're very familiar with. Perhaps you have at home with the children.
Risk? I wonder if you could do risk. No?
Gross. Gross. No, yeah, I'm sure someone has done some of the math on that, but gross. Because different players, different number of players. Oh my gosh, how many are you attacking with? No. Keep it. What's that?
Tic-tac-toe.
Oh, there you go. Yeah, sure. Exactly.
Tic-tac-toe.
Exactly. All right.